Are you driving?
I am driving. So again, sorry about that technical difficulty. You always plan for everything you can think of, and then High Sierra happens. That's what I'm blaming it on. So nonetheless, here we are. So as mentioned, I'm Lukas Ruebbelke.
And I'm Brennan. And today we're going to introduce components as thin clients. We're going to take you on a journey through space and time, and then we'll circle back around to talk about how this might relate to the work you're doing back at home. But first, let's start at the beginning with story time. How many of you have ever tried to build a jQuery application?
Don't be shy. We've all done it. Let's just be honest.
Sadly, me too. So back when we used jQuery, it was all about the DOM. Maybe you heard the term single source of truth. Well, back then, the DOM was our single source of truth, and we used jQuery to manipulate it. This was pretty cool in its day, but there was only so much we could do because the DOM was static. Then along came AngularJS. Suddenly, we had controllers to separate from the DOM. This allowed us to decouple our business logic from the DOM into our controller, and the controller became our single source of truth. However, our applications quickly grew and became more complex. Often we needed to pass information between controllers, and sometimes this got tricky. So we would create a shared service, and the single source of truth lived there. But our applications continued to grow, and soon we had many services, and our single source of truth wasn't so single anymore. Now, this was fine because we were rocking and rolling with all these cool features. However, it started to get confusing. It was common to have a service that would communicate with a remote server and at the same time manage state. We were mixing business logic with state management. So then along came Redux and solved this problem for us by splitting the logic into reducers and the state management into the application store, and the store gave us back our single source of truth.
Now, what I want to call out here is notice the pattern that as our application grows in complexity, that the important pieces of the application is moving further and further away from the component. And therefore, it's getting thinner and thinner. So just notice, we're starting with the DOM, controller, service, now we're in the application store.
But Lukas, what does that have to do with space and time?
So I read a quote the other day, and this is from The Theoretical Minimum by Leonard Susskind. Excellent book. And in this book, he says, in classical physics, if you know everything about a system at some instance of time, and you also know the equations that govern how the system changes, then you can predict the future. That's what we mean when we say that the classical laws of physics are deterministic. If we can say the same thing, but with the past and future reversed, the same equations tell you everything about the past. Such a system is called reversible. So this really jumped out to me because I believe this is the same mental model that we should apply to our application development. Now, I'm certain some of us are having one of these moments right here.
What? I know, Lukas, like, what did that mean? How does that relate to Angular?
So let's step through this. If we know everything about a system in time, at any given point of time, that's our single source of truth. This is also known as store. Carrying this along, where are the equations that govern how our application changes? Well, in this case, this is reducers. And because our reducers are pure methods performing immutable operations, it gives us transparency, referential transparency, that allows us to have a starting point that if we know the sequence of steps through the reducers, we can accurately define or know or calculate what the ending state is going to be. Also, conversely, if we have an endpoint and we know the steps that brought it to that point through the reducer, we can essentially step backwards and recreate historical state. But to really understand how this works, we have to start with the relationship between user input and its response.
Typically, we think of user interactions in this sense. There's a user-generated event, which immediately fires some unit of logic within the event handler. This relationship restricts what we can do in an application because it binds us to a very specific window of time and space. But we can create separation between event and handler by using actions. Instead of thinking of user events as event response, think of user events as event action dispatch response. So we're using the observer pattern to decouple events from responses. This allows us to manipulate time by modifying the cadence in which the events are processed. We can also start to play with space because we can bypass the DOM event entirely and produce the corresponding action somewhere else.
And so at a high level, what we're proposing is by redefining how we think about interactions, we can change the way that our application, or how an application experiences time and space. So notice here that all of the interesting things are happening outside of the component. So if you've been paying attention to what Rob Wormald is doing with Angular elements, by creating very thin components that live everywhere, this is a philosophical cousin to that idea. So now that we've laid the theoretical groundwork, let's anchor this in some real examples.
First, we'll start with space, which will be our manual dispatch. On the top, we respond to a click event by dispatching an action object into our reducers. Click, action dispatch, response. In the upside down, we can produce the same result by dispatching the same action, just without the user. So if we had an array of action objects, we could manually step through them one by one and dispatch them into the application. It looks like this.
So I think it's time for a demo. So hopping into our browser, notice here that when I click, we're simply selecting an object and it's responding. Let me bump this up. Thank you, Jeff. You are the best. So we're just clicking here, and this makes a lot of sense.
He said zoom.
Zoom.
A lot said zoom.
I'm getting a lot of confusing input here. So with that said, we have some actions here, and we can step through. So notice now we're creating space between what was typically click, see it. And so if I go step, we're simply side-loading these actions in and affecting the state of our application. And so now, remember, we're creating space between actually clicking and doing it or side-loading actions.
Okay, we saw space represented in the manual dispatch. Now we'll represent time in the manual cycle step. This allows us to dispatch a series of actions. So in this cycle function, we're stepping through actions. However, now we add time to dispatch them at specified intervals.
So again, it's demo time. So back to the browser. All right. So the screen I'm looking at is actually down here. So this is a new experience. All right. So if I click cycle, notice that we're stepping through these actions at a specified interval. It's set at half a second. What I can also do is drag this over to a single second. And now look, I'm recreating the same series of actions, but at a much quicker cadence. So now we're not only starting to play with space, but we're also starting to play with time.
So dynamic dispatch is similar to manual dispatch, except that we want to show that actions can come from anywhere, and space becomes even more irrelevant. So in this fetch single function, we're getting an action from a service, and then we just dispatch it like we did before.
Wait for it. All right, so I'm fetching an action from a REST endpoint. So this is actually from somewhere else. And from here, I can click dispatch. But what I can also do is I could go and let me just, lost my place. Let's go back here. Let's do a different action. Oh, come on. Go back to regular size and see if I can get this to work. So let's go client create, and let's create a new client. We'll say Robin Wormald. And we'll just give this a unique ID. Okay, and so now, let's dispatch this. And hopefully, yes, you can see that we have Raman Wormald is now a user or a client in our application. So we're able to do this from the side, but pull that action in from a remote service. So we're saying that now distance is irrelevant because we can pull it from anywhere.
And now I bet you can guess what we're going to do in the dynamic cycle. We dispatch a whole cycle of actions with just one step. If a user event is an action, then a user session is a collection of actions. So in this dynamic cycle, we would represent a user session. This fetch all is similar to the fetch function, except that it retrieves multiple actions rather than just one. And dispatch cycle, just like it sounds, will cycle through each action and dispatch them. Notice we see interval again here because we're playing with time. We didn't get the demo time. We didn't get the little dancing gif.
You know, in our mind, we are doing the demo time. So fetch, see here that we've just pulled in a collection of action objects, and we're just going to dispatch. And so now notice, pulling in a series of actions from somewhere else, cycling over them. So just maybe, we are going to talk about this, but start to think of how you could actually apply this in your own work and what the implications are. All right, are you happy?
Oh, yes,
okay.
Thank you.
Moving on.
So what if you have multiple users across multiple devices? Let's add another element of space with remote dispatch. For this step, we're using Firebase. However, there are several ways you could do this, such as GraphQL subscriptions, Socket.io, etc. Once we add Firebase, we can literally reach across space, and check this out. Now we can communicate with all our clients across space and time. Here's the code. We've injected Angular Firestore, which is a great Firebase client for Angular. Then we subscribe to the remote actions observable, which we automatically dispatch to our store. Lastly, we have dispatch remote, which allows us to add new actions to the remote actions observable.
All right. I can't skip this slide anymore. Bonnie said so. All right. So let's see what this looks like. Remote step. So we have it in here, but what I need to do is we now have two connected clients. And so if I dispatch this, you can see here that it also updated in the other client. So the idea is that now Firebase is sitting in between, as an event bus, is essentially communicating the equivalent action or the same action to multiple clients, and every connected client is then responding appropriately. So we're moving from a click event updating to now all the way into some essentially remote real-time event bus using Firebase.
Lukas said past and future, but we've only manipulated time into the future. How do we rewind time to visit the past? Redux makes it easy to rewind an action. Here we have a meta reducer with an initial state of past, present, and future. Then we have a switch case with undo and redo, and this lets us move forward and backwards through time by popping actions on and off the state. So we've basically built the Redux dev tools, and now we're time travelers.
Oh, come on. We've got at least one fan here. And so just undo, redo, but notice if I go undo, that we can start to step backwards, and we can start to step forward. So this is back to the quote, that if we know the state and the steps that got it there, we can then step through it or step backwards and either predict the future or recreate past state. So using a meta reducer, this is actually quite easy. So we've covered a bunch of kind of fancy sounding science stuff, but how does this translate to our day-to-day jobs? Like, what Jeff is going to ask me after this is like, how do I use this to make money, man? And so This is really, literally, in his case, the million-dollar question. Like, he is going to ask me, how do I make $1 million with what you've just told me? So, Bonnie, I delegate to you this responsibility.
Well, you can use this in a number of ways. The first thing that jumped out at me was QA. This would allow end-to-end testing without the need for someone to sit there and actually click all day long. Real-time support, you could use the remote dispatch cycle to sync a client's state for a user who might be having problems or confused. You could just go through that whole session remotely. Automating repetitive tasks such as data entry. This one is my personal favorite because in a prior life, before I was a developer, I was actually an admin, and I hated sitting there and filling out, boring stuff all day. Data entry was just boring for me. So one of the reasons I became a developer was so that I could automate tasks just like that.
And it's bonus slide time. So I think one of the best part of conferences is the awesome people that you get to meet. So to prove this point, I had the privilege of meeting Alex Castillo.
Yeah, I met Alex Castillo too.
Yeah,
he's
amazing. Great. So I was sharing my ideas about the possibilities of playing with time and space, and I mentioned how we could use it for debugging air states. And he instantly just lit up. He's like, I gotta tell you something. I gotta show you something. I gotta tell you something. And so Alex works at Netflix, and he created this Redux middleware that whenever your application throws an error, it captures that current state and the action that threw the error, and it siphons it off to Airbrake, which is a third-party logging platform. And so Redux makes this really nice because at any given time, we know everything about a system, and we also know the action that put it into an error state. And so by having those two pieces, we can create the state before the error, feed in the action, and then we have the error state. So this is really, really nice for when you throw a production error, saying, give me the state before, give me the action that called it, and then you can replay it. So this is a bonus slide. I just wanted to put it in there. So they used it on his team at Netflix. If you see Alice, give him a high five. Super nice guy. And I pretty much think he just #nailed this. So this is one very specific way that you can start to kind of use these concepts. But I want to leave you with one last demo. So we've been talking about the possibilities of space and time when you make your components really thin. And clearly we've referenced Redux heavily, and because that's what makes this possible. And obviously we've been using Redux for our demos, but I haven't been entirely forthright with how we are implementing it. So we're still using actions. It's a simplified version, but we're using actions and a classic reducer. And as far as our client's component is concerned, it's business as usual. It calls store.select, and it's store.select and store.dispatch, and essentially it streams all the way down. But we've simplified the store a little bit, but this is the beauty of Redux, is that you can write Redux from scratch in about 10 minutes. So we have a slightly simplified store, but the interesting part is our Redux implementation isn't in our Angular application at all. It is in Node using Socket.io. In fact, other than some unrelated demo stuff, there's only one service in our application that's actually doing work in the application. So I'm certain that there's more elegant and proper ways to do this, but I was able to recreate the parts of NGRX that I use, and the components have no idea that they are all alone in the universe. And so this arrangement creates kind of an interesting possibility that obligatory demo time slide, and let's see what this looks like. Because now our application is incredibly thin, and our state and our business logic is now in Node, communicating via Socket.io, that when I start to interact with the application, you'll notice that in the second window, it also starts to update because it's sharing the same state, and it's able to synchronize by sending actions back and forth. So if I delete Robin, it's gone on both sides. And if we create a new user, We'll just go test, test, and test, because if you can believe it or not, this is a test. Notice that in both windows, it's showing up. But then I can hop over here, and I can go like this and say, let's update the company to Llama Love. I think that's Shai's new startup. And in both cases, because, again, we're moving all the interesting pieces away from the component into, essentially, a Socket.io server, that our application is literally a bunch of components. And as far as my component is concerned, there's nothing special about it. It doesn't know that I'm in an application and it's only components. We have one really small service that essentially proxies that back and forth. So back to the slides. If you want to check this code out, onehungrymind/component-thin clients. And Jeff, this is where you're going to make your money. Just hedge off that burn rate, I think, this is your ticket. So you can find me on Twitter. It's Simpleton.
And I'm Bonster75.
And
big thanks to the amazing AngularConnect organizers for having us.
And thank you for coming, well, in this case, back to watch us. We don't take that lightly. It means a lot to us. And above all, we love you, and thanks.